Mars has been called the death planet, with good reason. It has been a spacecraft graveyard. More than half of the missions sent here have failed. NASA's success rate is better than other nations. But in 1999, the space agency's Jet Propulsion Laboratory experienced 4 unexpected and painful public losses when an orbiter, a lander, and 2 microprobes upon arriving were never heard from again. As if to taunt its victories, Mars dared that it be challenged again in 2003, a time the red planet would be the nearest to Earth that it had been in 60,000 years. The last time these 2 planets were this close, Neanderthals roamed the Earth. Wanting to regain its confidence, JPL took up the Martian dare, and then doubled down by agreeing to build and land on Mars not 1, but 2 rovers. Something never before attempted.
Expected parachute deploy in 5 seconds.
This is the triumphant story of spirit and opportunity. 2 rovers that survived the ordeal of landing on Mars.
1, mark.
T-minus 10, 9, 8, 7, 6 green board, 5, 4, 3, 2, 1, engine start, and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
Load relief kick rate is in, vehicles responding. We're approaching Mach 1. And there we go. We've exceeded the supersonic speed, and the engine positions look good.
Just watching it get up and off the pad and shoot off into the sky is a fantastic feeling.
Onboard video system working perfectly, sending back an immaculate image. We're now passing an altitude of 4 nautical miles.
It brings so much closure to what you've been doing that you have to be happy about that.
Just coming up on 2,000 miles per hour. Passing T plus 60 seconds, our solid motors have burned out.
But until you see the launch vehicle separate and spin down,
like a nice crisp jettison from the fairing,
and turn on the star scanners and exercise its propulsion system, find out where the temperatures are going to level out, understanding whether the solar panels are generating the power they're supposed to be. Until you see all that kind of settle in, it was hard for me to relax.
Now we're looking at a height of average of 90.0 nautical miles, extremely close to our nominal predicted orbit. Okay, we've entered a coast phase of the mission.
The journeys to Mars for Spirit and Opportunity would take 7 months, crossing a distance of some 300 million miles. This cruise portion of a planetary mission can be a relatively quiet time, but not for these 2 spacecraft.
While we are acquiring global image, receiving the PDF full packet box.
So just in the last hours, we haven't moved very much.
A lot of people think cruise is easy because we're just cruising along. You know, there was this animation of the Mir spacecraft, and you saw it launch, and you saw the excitement of the different stages coming off. And then it starts going on its way to Mars and sails off into the sunset. And then it says 7 months later. Well, those 7 months, that's really what we're concerned with. We have to work hard.
Currently Mach 16.6, altitude of 30.
While navigators plotted trajectories, the flight team practiced the complex landing sequences that are called EDL, short for entry, descent, and landing, but also known as 6 minutes of terror. EDL is the most complicated and dangerous part of any mission trying to reach the Martian surface. In a matter of minutes, multiple spacecraft transformations have to take place. It begins with separating from the cruise stage. Next, the rover, enclosed in a capsule, hits the atmosphere at 12,000 miles per hour. 4 minutes later, the speed has been reduced to 1,000 miles per hour, slow enough for a supersonic parachute to deploy without shredding. Then the heat shield jettisons, and the lander begins rappelling down a metal tape and a rope bridle. Meanwhile, a computer is calculating information about motion and altitude. Only seconds remain before the airbags inflate, the rockets fire, the metal tape and bridle rope are cut, and the lander free falls to the surface. The first bounce could be as high as a 4-story building, followed by more bounces that could go on for half a mile before the lander, with the rover tightly wrapped inside, comes to a rest. Hopefully, in one piece. The 6 minutes of EDL terror is still months away. Part of this time is used for training, what engineers call operational readiness tests.
Lucky peanuts.
The tests are meant to be as realistic as possible, including the JPL tradition of munching on peanuts for good luck. But this test is not going according to plan.
Flight, this is Testbed. The CDS should not be listening at this time. We have our system set up that is not sending data.
A processor fatal fault.
Unknown to the team, mission planners have inserted unanticipated technical gremlins into the drill to see how the team will react. The results of early rehearsals were closer to 6 minutes of errors than terror.
Do we know when the fail occurred to see whether this is enough time to recover Celestial?
It occurred sometime after we got the last packet, because it would have shown up as a tone in tone queue.
2 negative dips and 1.
We actually had 3 or 4 simulations where we would sit in the mission control room and we would pretend like the real thing was happening. It was a good thing we did, because the first time we tried this, it was a sheer disaster.
There's actually a small chance we did actually fail between now. I've got test artifacts now.
We are now about 26 minutes from entry. Velocity 5,250 meters per second.
Wayne Lee managed the rover's entry, descent, and landing system that is responsible for getting the rovers down on the ground. During the actual landings, he will be in a different kind of hot seat, as the voice of mission control.
Now, 4, 3, 2, 1. Mark, we now have cruise stage jettison.
I kind of said to myself, on that day, I have no control over it.
Much of the information Lee will be calling out will come from Polly Estabrook.
EDLCOM, we are still receiving acceleration tone number 1.
Estabrook's job is to interpret 36 radio frequencies being transmitted back to Earth during EDL. These tones will indicate critical engineering events the spacecraft is supposed to perform.
If anything went wrong with the mission, telecom was going to tell the answer. But I don't see the Doppler rate and the frequencies. I went to work thinking, I don't know, how did I get into this situation? My fear was, if something bad happens, I should be able to say from the signature of the signal what has happened.
Mark, at this time, the parachute should have deployed under the nominal trajectory.
I was very nervous.
At this time, it is expected, based on the pre-entry predicts, the vehicle should be on the ground. We are waiting for telecom confirmation that has happened.
EDLCOM, we are bouncing on the surface.
Another unexpected event, but one all too real, occurred 68 days before the first rover landing. It was the day the sun erupted. It was the third most powerful solar storm ever recorded. When this massive solar flare reached the Earth, communications networks were disrupted. Airlines diverted their routes, Earth-orbiting satellites temporarily went dark, and astronauts aboard the space station sought emergency shelter.
And this huge amount of material, bigger than the sun itself, went flying off of the sun out towards the planets, out towards Earth, out towards Mars, and out towards our spacecraft.
When the solar flare reached the two spacecraft, their star sensors, essential for navigation, began seeing flashes that they mistook for stars. The two spacecraft were all but blinded by the flare. Fortunately, there was no major damage, and the star sensors eventually came back online. But nature wasn't done with surprises. In December, as the first landing day drew near, dust storms began blowing up on Mars, and that was a cause for alarm. Dust causes the Martian atmosphere to warm and thin. That meant the parachute would move through the atmosphere at a faster speed, resulting in less time for slowing down. To counter this condition, Spirit's parachute was reprogrammed to open 2 seconds earlier in hopes of gaining back lost time. Meanwhile, other team members were continuously running computer simulations of EDL, trying out different parameters to see what might occur.
Yeah, so that's what you're looking for?
Yeah. Much to our surprise, after months and months and months of successful round-the-clock testing, we finally find that there's some failures that are occurring. We said, well, is it fluke? What's going on? What we've discovered is that the software is trying to turn on timers that count down to firing pyrotechnic events. A pyrotechnic event is an event that, say, opens up the parachute or inflates the airbags or fires the rocket. All those things are controlled by pyrotechnic devices and little timers that the software can control. We're finding that the software wasn't getting around to doing it. And there was a problem between the hardware and software that we did not know about until just 2 days before landing. And in which case we'll have a failure, guaranteed failure. We're pretty nervous about this.
More testing provided no definitive answer, leaving engineers in agony over what to do or not do. With time running out, the decision was made to manually enable the hardware that fires the pyros by sending commands directly to the spacecraft an hour before landing. There was still more bad news coming from Mars. On Christmas Day, Britain's Beagle 2 lander entered the Martian atmosphere and was never heard from again. A few days later, as 2003 was ending, the Japanese Space Agency announced that its Mars mission had failed to go into orbit. Of the fleet that left for Mars that year, only the European Space Agency's Mars Express orbiter had so far survived its arrival. And now, it was the rover's turn.